All right, January 2018, question 10a. Question says, the diagram below not drawn to scale shows a circle with center O. The points A, B, and C are on the circumference of the circle. We're told that EAF and EDG are tangents to the circle at A and D respectively. Angles AOD is equal to 114 degrees and angle CDG is equal to 18 degrees. So essentially they're telling us what we can see for ourselves. The first thing we're asked to do is to calculate, given reasons for each step of your answer, the measure of angle ACD. So they want us to say what is angle ACD. All right, let's identify that angle. It's angle ACD. So this is the angle I want us to find. It's angle ACD. ACD. I want us to find this angle here. All right, so immediately I can see that angle ACD is equal to 114 divided by 2, which is equal to 57 degrees. So this angle is 57 degrees. And essentially the reason is this, that the angle at center is equal to 2 times the angle at circumference. Alright, the angle at the center of a circle is equal to 2 times the angle at the circumference. Essentially, we need to be able to identify, well, how do we identify angle at the center and angle at the circumference? Both of them must start and end at the same point. So both angles start at A and end at D. One goes to the center, the angle AOD is the angle at the center, and angle ACD is at the circumference. So both angles start and end at what? A and D. One goes to the center of the circle, angle AOD, and the other one goes to the circle, the circumference of the circle, angle ACD. Angle AOD is called the angle at the center, and angle ACD is called the angle at the circumference, and it's equal to 57 degrees. Next, we're asked to determine the size of angle AED, angle AED, angle AED. They want us to find this angle here. All right, here's what we can point out. We can point out that angle OA angle OAE is equal to angle ODE, and they're both equal to 90 degrees because the radius at point of contact is at right angles to tangent. All right, so that's another circle theorem. The radius at the point of contact is at right angles to the tangent. So what I just showed you is that this angle here is 90 degrees and that this angle here is 90 degrees. And maybe we could make those a little smaller. So the angle here is 90 degrees and the angle here is 90 degrees. Now OAED is a quadrilateral and the angles in a quadrilateral add up to 360 degrees. So angle AED D would be equal to 360 minus 90 plus 90 plus 114 degrees. This is 360 minus 294 degrees. This angle here is 66 degrees. So the angle here is 66 degrees. And that is coming from the fact that OAEB is a quadrilateral, and the angles in a quadrilateral add up to 360 degrees. Next, we're asked to find angle OAC. We're asked to find angle OAC. So that's this angle here, this little angle here. All right, how are we going to find it? All right, I'm going to start out by finding this entire angle here. This entire angle here. All right. All right, so I'm going to start out by finding this angle here. Now, OA is a radius and OD is also a radius. So that makes triangle OAD an isosceles triangle. Angle O is the apex and BD is the base. And the base angles of an isosceles triangle are equal. So I'm going to say that 2 theta plus 114 degrees would be equal to 180. And these are the interior angles of an isosceles triangle. So 2 theta would be equal to 180 minus 114, which would be equal to 66 degrees. So theta, or divide both sides by 2, would be equal to 66 over 2. So therefore, theta, which is angle, go back up, angle OAD, angle OAD is equal to 33 degrees. So this entire angle here, OAD, is 33 degrees. Now I can also find this piece. I'm going to call it alpha. All right, and that is alpha is angle CAD. Now, angle CAD is equal to 18 degrees. And the reason for that is that the radius, sorry, it's not radius. The reason for this is that the angle between tangent and chord at point of contact is equal to angle in alternate segment. All right, so let's go back up to examine that. Now here we have what? CD. D, first of all, is the point of contact. CD is a chord, and the chord divides the circle into segments. So this piece of the what? Circle is the minor segment, and the rest of the circle would be the major segment. Now, that 18 degree there, angle CDG, which is 18 degrees, is the angle between the what? Is the angle between the tangent and the chord. The angle between the tangent and the chord is equal to the angle in the alternate segment, which is here. It's equal to 18 degrees. Let me just see if I can just do a quick illustration. All right, it's like this. Is 18. All right. My drawing not going so great, but let's try again. All right, a little better. Point of contact, chord, if this angle here is 18, and then I have something like this angle here would also be 18. All right, so that is the reason. The angle between the tangent and chord at the point of contact is equal to the angle in the alternate segment. Now, the entire angle OAD is 33 degrees and CAD is 18 degrees. So therefore, the other piece, which is angle OAC, would be 33 minus 18. So therefore, angle OAC would be equal to 33 minus 18, which would be 15 degrees. All right, the last angle we're asked to find is angle ABC. Let's identify it, angle ABC. So the last angle we're being asked to find is angle ABC. All right, piece of it, what I'm going to use for that is that ABCD is a cyclic quadrilateral, and that opposite angles of a cyclic quadrilateral are supplementary. Therefore, if I know this angle here, if I know this entire angle here, and I take it away from 180, I will get this angle. These two angles are opposite angles of a cyclic quadrilateral. So that is the angle at B, and this entire angle here at D. Opposite angles of a cyclic quadrilateral are equal. Now this piece I already know. This piece is theta, which is 33 degrees. What I need is the other piece over here. All right, and that's not so hard to find either. Let's call this beta. So that piece beta there, beta would be equal to 90 minus the 33, and this would be equal to 57 degrees. Is it 57? Yeah, 57. So this angle here is 57 degrees. Now, if 57 and 33, sorry, nope, it's not incorrect. It's supposed to be 90 minus 18. Angle ODG is 90 degrees, but this piece, so ODG is 90 and this little piece is 18. So if I take away 18 from 90, I would get this piece here, which is beta. So it's actually 90 minus 18. 90 minus 18, and 90 minus 18, which would be 60, which would be 72 degrees. So this is 72 degrees. So one piece is 72 and the other piece is 33. So this is 33 plus 72. So angle ABC, angle ABC would be equal to 180 minus the 33 plus the 72, which would be 180 minus the minus 105. So this would be 75 degrees. And I can then see that they're opposite angles of a cyclic quadrilateral. All right, opposite angles of a cyclic quadrilateral are 280. So let's recap a little for that last question. I found this entire ODG is 90, but this piece of that angle here, 18, take away 18 from 90, I get here is what, 72. There's 72, and here we already found is 33. So 72 plus 33 is 105. If you take away 105 from 180, you're going to get the angle here at B, because they're opposite angles of a cyclic quadrilateral, and opposite angles of a cyclic quadrilateral are supplementary. So the angle here is 75 degrees.